First of all, what is interest? So it's money paid into a bank account by the bank as a thank you for investing with them. And the first type of these that we'll look at is simple interest. Now, this is actually a fixed amount of interest that is paid each year. And crucially, it's calculated as soon as you invest your money. So your initial amount is the amount that your interest rate is calculated on. Okay, so $5,000 in this first example is invested at a rate of 6% simple interest for 30 years. Now, the first job that I've got here is to find what 6% is. Okay, so 6% I know is 0.06. Could also choose to use my percentage button on the calculator if I like. All right, and my job is to calculate the balance of the account after 30 years. Now, I've just worked out that 6% of $5,000 is $300. Okay, and that is actually given by the bank for 30 years running. Okay, so $300 multiplied by 30, if my calculations are correct, is $9,000. So calculate the balance of the account after 30 years. Well, $5,000 went in at the beginning. Over the course of the 30 years, I've just accumulated $9,000 more dollars. So my calculations tell me that I've got $14,000 at the end of the 30 years. Now, that might seem okay. That might seem like a good deal to some of you. However, it's not. It's a complete rip-off, okay? We do not generally go for simple interest accounts, and that, unless the interest rate is really high. For the simple reason that it's not really fair to just get interest based on your initial amount. Your balance is increasing massively over the course of that 30 years. Okay, so imagine this. Imagine that you were to actually think about how much money you had after 10 years here. And you could have actually taken your money out at that point and reinvested it. 6% at that point would have been far more than $300. Okay, we could even work it out. So if I'm getting $300 for those first 10 years, okay, I've got an extra $3,000 in my account on top of the $5,000. So that would mean that after 10 years, based on that scenario, I'd have $8,000. Okay. And actually, if I was to do that times 0.06, I'd be getting $480 per year instead of $300. Okay, so you can see that actually it's a massive rip-off. All right, we should not be doing simple interest, although questions do pop up in exams about simple interest. Okay, but it's not a good strategy. What's even better is that you need to look at compound interest, okay, in your savings in the future, generally. Okay, compound interest results in much greater increases in wealth, and I will show you why. We're going to use exactly the same initial amount and interest rate, 30 years, but this time we're going to be looking at it in a compound interest scenario. The interest paid each year increases in line with the increasing bank balance. Okay, so let's think about this. We've got $5,000, and first year, okay, we know this is 300. So at the end of this, okay, at the end of this first year, we've actually got $5,300. Okay, so this is year one. Year two, okay, I've now got $5,300, and I'm finding 6% of this. Okay, now what's that value? That would be, let's work this out. That would actually be 318. So we got slightly more interest that year. It's only this year two. Okay, so my balance now is 5618. Okay, year three, 5618 times by 0.06 is equal to 337.08. Okay, so my balance now is 5955.08. Now, I'm not going to sit here and do this for 30 years. Okay, it's pretty time consuming. So what I'm going to realize, okay, and what I'm actually just going to teach you now, is that if I do 5618 divided by 5300, I get 1.06. times 1.06 times 1.06 as well. If I do that one divided by that one, my multiplier to go from one to the next is times 1.06. And that makes logical sense because actually this one here, okay, my 5,000, 106% of that, so 100% of it with 6% added on is 5,300. You can try that if you like, okay, on your calculator, okay? And then finding 106% of that, so 100% of it with 6% added on, and then 100% of it with 6% added on is that one, and so on, okay? So what I really need to be doing, actually, is 5,000 times by 1.06, finding 106% of each, each of the consecutive values after it 30 times, okay, to the power 30, okay, because it actually happens 30 times. Year 1 times 1.06 times 1.06 into year 2 times 1.06 the third time again for year 3, and times 1.06 would give me the 4th year balance, okay? I'm going to do that 30 times. And actually, I can work it out with my calculator super quickly by realizing that that is happening and get a value of, my final value after 30 years is actually, in dollars, 28,717.46. Now, if we compare that to my paltry 14,000, if it was simple interest, I've more than doubled my amount. Compound interest is a winner, okay? We always go for compound interest. I'm going to give you a quick general formula now for compound interest. It's a little bit more difficult to remember, but it's worth the marks, and it's worth just the general knowledge for life as well. Okay, so what we need to know is that if we want to know our final balance, okay, balance is going to be the payment, the initial payment, call it P0, 1 plus R to the power N. Okay, I'm just going to define these things here. So this is my, balance. In that case, it was my balance after 30 years, the balance of the account. This is my initial payment. This is just number 1 plus the interest rate as a decimal. Okay, so e.g. 6% was 0.06. And this is my number of years. All right. Now then, I'm going to go and do another example now and show you that. Okay, so we're going to use that formula. In fact, I will take a screenshot of it and I will have it in the corner as we do this next one. So look. I'm actually going to go straight to EG2. We'll do this in a little bit of a different way, but I think we need to practice this straight away. Okay, so let's just make this a little bit smaller. Have that there. Okay, so let's put these values in. My first value, my initial payment in this question, if you deposit £1,000, okay, so it's £1,000 going in, which is paying 3% compound interest. So my R is 0.03, and how much interest would be in the account would be earned over 3 years, so N is 3. Okay, so I'm just going to put these values in. The balance would be 1,000 times by 1 plus 0.03 to the power of 3, and the answer there would be 1,000 times by 1.03 to the power of 3 is equal to, 1092.727. Obviously, it's money, so it's going to be in pounds as well. 1092. As well as it in pounds and pence, so it's going to be 73. Okay, all right, easy as that. That's compound interest. That's what you need. That's what you need to be able to remember in order to do it. And it gets easier. The more examples you do, the better. Let's just do one more. Let's go back to simple interest and remind ourselves how, silly this is, really. You wouldn't go for one of these. £250 in a bank account, paying 5% interest per year. How much simple interest will be earned? Okay, there's a subtle difference in the question. We'll discuss this in a minute. But let's just go and find what 5% of this is, first of all. So 250 times 0.05 is £12.50, £12.5. Get that for 5 years. So times that by 5, £62.50. And that is how much simple interest will be earned. So actually we've answered the question. We don't have to go and add it back onto the 250 or anything. That's the answer. Okay. Really easy questions to answer. Okay. But obviously if it was compound interest, we would be earning a lot more. So I hope that's been nice and clear. And any questions, any other things that you would like to know, or any more requests, please don't hesitate to ask.